In this question, we are given information about a Ferris wheel, and we are told that the height of P, a point on the wheel, after t minutes is given by the function ht equals to a cosine bt plus c. We have to find the values of a, b, and c. We are told that when the wheel starts moving, so at t equals 0, P is at the lowest point, so here. Let's sketch how function ht looks like to help us better visualize the situation. On the horizontal axis, we have time, so t, and on the vertical axis, we have height, so ht. The graph starts at t equals 0. Let's assume that the t-axis is at ground level, so on this axis, the height, so ht, is 0. When the wheel starts moving, P is at its lowest point, which, as shown in the diagram, is 10 meters above the ground. Therefore, the graph starts where ht is 10. The graph is a cosine graph, so it looks like a wave, and one period of the graph can be drawn like this. We are given that the diameter of the wheel is 110 meters, so when P is at its highest point, it is 110 plus 10 meters, so 120 meters above the ground. Therefore, at the maximum point of our graph, ht is 120. We are also told that it takes the wheel 20 minutes to complete one full revolution. This means that after one period of the graph, so here, t is 20 minutes. Let's now figure out the values of a, b, and c. Let's begin with c, which shows us the principal axis of the graph. The principal axis is halfway between the minimum point and the maximum point, so it can be drawn like this. To find the number halfway between 10 and 120, we'll add 120 and 10 and divide the result by 2. This gives us 65. Therefore, c is 65. The letter a in this equation shows us the amplitude. One way to find the amplitude is to figure out the distance between the principal axis and the maximum point of the graph. So the amplitude on our diagram is here. To find this distance, we'll subtract 65 from 120, which gives us 55. We'll come back to this number when we write down our final answer. Now let's move on to find the value of b. b is related to the period of the graph in the following way. The period is equal to 2 pi over b. Since the period here is 20 minutes, we can write that 20 is equal to 2 pi over b. Now we are ready to give our final answer, so the values of a, b, and c. As we said, a shows us the amplitude, so its absolute value is 55. However, since here the graph starts at its minimum point, a is equal to negative 55. Rearranging the equation for b, we get that it is equal to 2 pi over 20, so pi over 10. You can also write this value as a decimal number. C shows us the principal axis, so it is equal to 65. An exam-taking tip that you can take away from here is that the meaning of the letters, here a, b, and c, in trigonometric function equations is not provided in the formula booklet, so make sure that you know to what features of the graph these letters are connected. Here, for instance, a is connected to the amplitude, b to the period, and c to the principal axis.